So today I want to talk about what happens when the F test is significant. Something like this. F, numerator, comma, denominator, degrees of freedom, and alpha over 2 goes here, and alpha over 2 goes here. This is the critical value, and your F naught falls here. And F naught was given by the larger s squared over the smaller s squared. So the F naught falls here, and therefore the F test is significant. So H naught used to be sigma 1 square equals sigma 2 square versus HA sigma 1 square not equal to sigma 2 square, and we're saying reject H naught in favor of HA. So we're saying sigma 1 square is not sigma 2 square. Therefore, use unpooled variance T-test, otherwise known as Welch-Sathert weight approximation. This one is actually easier than the pooled one. So recall that my Z naught test statistic used to be x bar minus y bar minus mu x minus mu y from the null divided by radical sigma x square over nx plus sigma y square over ny. This was my base case formula, right? And so the difference, the changes that I make are these. This becomes T naught, and this, instead of saying sigma x squared, becomes sx squared, and this one becomes sy squared. So it's actually, there's nothing pooled, there's nothing like that. The previous case was actually more complicated. This one is not. So T naught is just x bar minus y bar minus mu x minus mu y over radical sx square over nx plus sy square over ny. The catch here is this is performed at new degrees of freedom, where new is given on page 11 of your notes. Let's go there. It's this horrible formula for the degrees of freedom. Look at this formula. S1 squared over N1 plus S2 squared over N2. Add them, square it, and then divide by this S1 squared over N1 squared divided by N1 minus 1. It's horrible. If you get this wrong, you get the degrees of freedom wrong, which means that the critical value will be wrong. So let the calculator do this. Do this on the calculator. And you also then have to round down. So this T-test is performed, here's a T, at new degrees of freedom, where I'm saying let the new come from the calculator. And let's say it's two-sided in this case. You go and you drop your T naught into one of these three regions and reject or do not reject accordingly. I'm going to do a problem right now. Let's say the T naught fell here. So my conclusion then would be reject H naught, that mu x equals mu y, in favor of HA, which says mu x not equal to mu y. And furthermore, you're in the right rejection region, T naught in right rejection region, so conclude that mu x minus mu y is greater than 0, or mu x greater than mu y. Follow what I'm saying? I want to do a real example. Let's do the example on page 12. So this Welsh Satterthwaite is sometimes spelled with a C after the S, and sometimes this C is omitted. Either way it's pronounced Satterthwaite. Okay, let's go to page 12. Suppose cholesterol levels are assessed in 100 case children, 2 to 14 years old, of men who have died from heart disease, and it is found that the mean cholesterol level in the group is 207.3 milligrams per deciliter. Okay, so I have cases and I have controls. So the cases are the children of people who have died of heart disease, and I have NX equals 100 case children, and the mean X bar is found to be 207.3, and the sample standard deviation is 35.6. And a group of control children whose fathers are alive and do not have heart disease are selected. The cholesterol levels of the case children will be compared to the cholesterol levels of the control children to see if there is a familial aggregation of cholesterol levels. The case and control children are taken from the same census tract but are not individually matched. Thus, these are considered two independent samples. The 74 control children, NY equals 74, have a mean of 193.4 and a sample standard deviation of 17.3. We would like to compare the means of these two groups to see if the case children have the same mean cholesterol level as the control children. So H naught mu x equals mu y versus HA mu x not equal to mu y. But we do not know whether the variances in the two groups are equal or not. Conduct a test to check for the equality of variances in the two groups. Okay, so first thing I do is a F test for comparison of variances. H naught sigma 1 square equals square, HA sigma 1 square not equal to sigma 2 square. It's always two-sided in our case. So I need to assign numerator and denominator to these two sides. So let's just look to see who has the bigger S. This is the larger S. Therefore, this is the numerator side and this is the denominator side. And the numerator degrees of freedom are n minus 1, which is 99. And the denominator degrees of freedom are this n minus 1, which is 73. So F naught is equal to S squared 35.6 over 17.3. Each of them is squared. So it looks like it's pretty big, right? This is a 2-to-1 ratio. So when I square the 2, it's going to become a 4. So I think it's going to, the F test will be significant because it's saying that F naught is going to be 4. It's how can they be coming from the same variance population if the ratio is 2-to-1? It doesn't make sense, right? So let's do the F test. I have this F. Numerator is 99 degrees of freedom, comma, denominator is 73 degrees of freedom. And then I go to my F table. And they didn't give me any alpha. So let's say here, no alpha is provided. No alpha provided. So let's use alpha equals 0.05 for F test. And I think no alpha was provided for the t-test either. Let me just make sure. Yeah, no alpha provided for F test or t-test. So alpha is equal to 0.05 for both. So 0.025, which is alpha over 2, goes here. And alpha over 2 equals 0.025 goes here also. I don't care about this one. I do care about this one. I want to make sure that I look up the proper 0.025 table for F. So let's go there. Not this one. This one, it says alpha equals 0.05, but they don't really mean alpha. They mean this area. So that's alpha over 2 equals 0.05. That's not the one I want. I go to the next one and I see alpha over 2 equals 0.025. So this is my table that I need to work with. The numerator degrees of freedom are 99. So I go here, these are the numerator degrees of freedom, and there's no 99. So I'm going to pick up 60. So let's make that modification right here. This is not there, so I'm going to use 60. And then 73 down the margin is also not there. I'm going to use 60 for that also. Follow me? So 60 and 60 and 025. So 60 and 60 gives me 1.667. 1.667. That's my critical value. And my F test statistic is, just grab my calculator, which is here somewhere.
Let's hold it.
Thank you. $35.6 divided by 17.3 and square it. 4.2345. 4.2345. So it falls here. F naught 4.2345 in the rejection region. So I see that the F test is significant and Welch-Sathert weight or unpooled is warranted. So let's do an unpooled T-test. So B says, based on the F test, what procedure would you use? That would be that. And then part C, your final will also be broken down just like this. C says